vocabulary words that are important for this chapter. The amplitude of the graph of each function is 1/2 of the difference of the maximum value and the minimum value. In other words, the amplitude is found when you subtract the very bottom value, and we're talking y value, from the tippy top value and divide that number by 2. Okay, so what does that mean exactly? That means that if we have a cosine or a sine function, we're taking this bottom and subtracting it from here. But here's the thing, and you'll see this in an upcoming, oh, it's a terrible picture, in an upcoming slide, is that when your function is cut in half by the x-axis, your amplitude is just your y-coordinate, okay? And I'll show you that in a second. Okay, but it's important to know the amplitude is how tall it is. A function is periodic if its graph has a repeating pattern. Okay, in other words, if you could cut a graph into identical pieces infinitely, the function would be periodic. So I thought of these little paper people. Obviously, this is not forever, but if you were to cut these down like this, you could stack them on top of each other and they'd be identical. But it goes over and over, so that's periodic. The shortest repeating portion of the graph is called a cycle. In other words, a cycle would be only one of these people. Okay. All right, I think you guys have fill in the blank. The horizontal length, this is important. The horizontal length of each cycle is called the period. In other words, the measure of one of these paper people's arm spans and leg spans. However, you can see they're the same. All right, but the period, that's a really important word. Amplitude and period. So amplitude is this way, period is this way. All right, here's that graph I was telling you about. So this is sine. It's going through 0, 0, and its amplitude is 1. It's actually going from -1 to 1, which is 2, and then you divide that by 2 to get 1. But your amplitude really is how tall half of it is. So if we moved this all the way up, like a couple of units, and it was, the middle here was 3, it would go from 2 to 4, but the amplitude would still be 1. The 2 minus 4. 4 minus 2 is 2, divided by 2 is 1. Okay. All right, I'm not going to redo that because I don't have time. All right, here's cosine. Again, you can see it starts at 0, 1, coasting down. Okay. So take a minute and determine whether the graph represents a periodic function, and if so, identify the period. Okay, well, just really quick, we can look at a function and just, take a point and look and see if it repeats itself, right? And I can go from anywhere. I can go from here to here, I can go from here to here, etc. But when we're figuring out the period, okay, it's best to start at 0. That way, I'm not trying to figure out the length between here and here. I'm finding the length between 0 and where it starts to repeat. Okay, so see if it's periodic. Of course it's periodic. But just take a second and identify the period or the length of that cycle. You can pause the video. You don't have to sit there and stare at me. Okay, so yes, it's periodic. We said that already. And if I'm starting at 0, it goes to about here. Now some of you might have said 6. It's kind of hard to tell. It's actually a little bit past 6. So maybe 6.28. Huh, what is 6.28? Well, half of that is 3.14, which is roughly pi. So the period here is 2 pi. Now, somebody asked me before, are all periods 2 pi? And the answer is no. Periods can be any length, and we'll see more of those. Okay. So y equals sine of x and y equals cosine x are parent functions, and like all other functions, they can be transformed. Boy, we're getting so good at this. Okay, but we're not actually going to talk about ones that, translations. We're not going to talk about back and forth and up and down today. But we are going to talk about vertical stretches and shrinks, and we haven't talked about it before, but horizontal stretches and shrinks, and they get a little confusing. So vertical stretches and shrinks do exactly what we've known them to do. It's a number times the function. Okay, so a times the function, it's a stretch if it's over 1, it's a shrink if it's between 0 and 1. And you can see here, in these two functions, here's your a. This is your vertical stretch and shrink. This is your amplitude, okay? Now, horizontal stretches and shrinks, a little bit different. You take the reciprocal, and the reciprocal tells you what's really happening. And I know that that's weird. But it says a horizontal stretch by a factor of 1 over b. Well, that seems weird. 1 over b doesn't sound like a stretch to me. Well, if b is between 0 and 1, so let's say it's a half, okay? That's actually a stretch, because when I do 1 over b, it's actually 2. 1 over 1 half, 1 divided by 1 half is 2. So that is actually a stretch. So a shrink is when I get a number bigger than 1. So let's say I have the number 4, but I'm taking its reciprocal, which is 1/4, so it's actually a shrink. And the horizontal stretches and shrinks are going to measure the period, okay? The horizontal stretches and shrinks. And those are the numbers that go right next to x. Okay. So again, let's just reiterate. The A is your vertical stretch and shrink, and your B value is horizontal. Stretch and shrink. Okay, let's see where we're at with time. You know what? This is perfect. We're going to, I have to make these videos in short little sections, so we are going to go on in the next video.